at another example. This next one is an acid and a base. So right, I'm going to figure out what kind of ions do I have present here. So acids always have an H plus in them. So this is sulfuric acid, so I've got H plus and SO4 2 minus. I have 2, that subscript 2 just came because the sulfate has a -2 charge, so I need 2 H pluses there. I'm not going to bring over the H2 with a charge. I'm not going to bring that subscript over on the product side unless I need to, but I don't bring it over right away. If it ends up with one, it's because of the anion that it's combining with, right? So there's 2 here because this anion has a -2 charge. So I've got calcium, and then I've got hydroxide. So I'm going to bring my cations over. I've got H plus, I've got calcium 2 plus, and then I'm going to switch the anions. So I get OH with this guy, and I've got SO4 2 minus over here. So HOH, I'm just going to keep that as HOH for when I try to balance. HOH is just water, and water is a liquid. Okay, so this is not going to dissociate into ions when I go to the complete ionic equation because it's a liquid, it's going to stay together. Calcium sulfate just becomes calcium sulfate. Good. So let's go back to our rules, our list of what we're doing. So we found, we were at cation, anion, cation, anion. We crisscrossed, we found our subscripts, so we made our formulas. We didn't bring over any subscripts in case, unless they're part of the polyatomic ions. So the 4 of the SO4 came over because it's part of the sulfate. Now we're going to balance, and then we'll determine, I already kind of did this part. I recognized that water was a liquid, so I just kept that. And then we'll use the solubility table to figure out anything about calcium sulfate. So I have 2 hydroxides, I have 2 H's over here. I'm just going to put a 2 in front of my water, and I'm balanced. Now I can look at this guy and try to figure out if he is a solid or is he aqueous, what's going on there. So we look at sulfates. All right, so you can see sulfates are usually soluble except with strontium, barium, mercury, and lead, and calcium is not one of those exceptions. So calcium sulfate is going to be soluble. So I can go over here and say calcium sulfate is going to be aqueous. Great. All right, so I balanced. I figured out I have a liquid on one side. I have a soluble ionic compound on the other. So now I'm going to identify which ones are the strong electrolytes. So for strong electrolytes, I'm looking for strong acids, strong bases, and soluble ionic compounds. This is my list of strong acids. Acids, again, the acids are going to be the ones that start with an H. The weak electrolytes or non-electrolytes are going to be solids, liquids. So we have water, water's a liquid. So that's going to be a weak electrolyte. If we had gases or weak acids for bases. Okay, so now we'll identify which ones are strong and which ones are not. So this is a strong acid. H2SO4 is a strong acid. It's on the strong acid list. Calcium hydroxide is also strong. There you go. There we go. H2SO4 is strong acid. Calcium hydroxide is actually a strong base. It's also a soluble ionic compound. It's a 2 for 1. So he's going to get a star. Liquid water, no star. He's not going to get a star. He's not a strong electrolyte. And then calcium sulfate is a strong electrolyte. Okay, so now everything with a star can dissociate into ions. So I have my sulfuric acid, 2 H pluses, SO4 2 minus, calcium, 2 hydroxides. I get my water, that's going to stay together. I'm going to call that H2O now because I already balanced it. You can keep it as HOH if you want to. That's a liquid that does not dissociate into ions. Calcium sulfate does. And then I can cancel things that are the same on both sides. I've got sulfate, calcium, calcium. All right, so I'm left with 2 H plus, 2 OH minus, 2 H2O with a liquid. And you see how I have 2, 2 to 2? I can write that with the simplest numbers, which would just be 1, 1 to 1. So I end up with H plus, aqueous, OH minus, aqueous, gives me H2O with a liquid. And my spectator ions are calcium and sulfate. And you'll see this a lot. This is if you have a strong acid and a strong base, that's always going to happen. You're going to get a soluble salt and liquid water.